Hello and welcome to GED Live at PALS. This is another GED Science practice test, the second one in 2021. If you find these videos helpful in preparing you for the GED tests, please subscribe to our YouTube channel so you won't miss any future content here helping you to pass your tests. Let's get started. Question 1 refers to the following photograph and chart. So in the chart we see the average temperature of various large bodies of water: Atlantic Ocean, Arctic Ocean, Baltic Sea, Great Lakes of North America, and the Gulf of Mexico. On the picture we can see a hurricane. We can see the temperatures of the different bodies that we just mentioned, and we can see that the coldest is the Arctic Ocean and the warmest is the Gulf of Mexico. So, first question. Hurricanes such as the one pictured above gather strength as they pass over warm water. According to the chart above, over which the following bodies of water would a hurricane gather the most strength? So, the question tells us that hurricanes gather the most strength as they pass over warm water. As we said earlier in our table, the Gulf of Mexico is the warmest body of water here with 60 degrees Fahrenheit on average, and that means the correct answer is going to be D for this question. Question 2. Blood is made up of two main elements: plasma, which is largely water and proteins, and the second, the solid components of the blood: red blood cells, white blood cells, and the blood platelets. If a patient has lost a lot of blood, he or she may receive a transfusion of whole blood, which includes red blood cells and plasma. However, sometimes the patient needs only an increase in the volume of liquid in the bloodstream, in which case plasma alone may be substituted. A person must be tested for blood type before receiving certain kinds of transfusions, because of differences in the ways that red blood cells react to one another. Under what conditions would such testing be necessary? A, for a whole blood transfusion only, for plasma transfusion only, for both whole blood transfusion and plasma transfusions. D, if the patient has not lost any blood. So again, what is the question here? Under what conditions would such testing be necessary? What testing are we talking about here in the question? It tells us earlier, person must be tested for blood type before receiving certain kinds of transfusion, because differences in the ways that red blood cells react to one another. Now, which blood transfusions contain red blood cells? It says us in the paragraph above, if a patient has lost a lot of blood, he or she may receive a transfusion of whole blood, which includes red blood cells and plasma. The other kind of transfusion is to increase the volume of liquid in the blood, and that is plasma alone. So plasma alone does not contain red blood cells. The testing we are talking about involves how red blood cells react to one another. So let's look which is the correct answer. We definitely can exclude D. If a patient has not lost any blood, he doesn't need a blood transfusion. And when a patient gets a plasma transfusion only, that doesn't contain red blood cells, so we do not need the blood to be tested, so we can exclude B as well. That means we can exclude C as well, which says both whole blood transfusion and plasma transfusion, so the correct answer here is A. We need to test for blood type when a person receives a whole blood transfusion that contains red blood cells. Question 3 through 5 are based on the following information. Coal is formed from the material of plants and other organisms that lived on land and whose remains were covered by mud, which later became rock. Coal is classified by carbon content. Different types of coal include peat, lignite, subbituminous coal, and anthracite. So peat are the remains of plants and organisms that, because they were covered in bogs, were prevented by a lack of oxygen from completely decaying. Still porous, soft brown mass, peat has a carbon content of 52 to 60%. Lignite, in time peat turns into lignite, a soft coal-like substance that is 60 to 65% carbon. Subbituminous coal, with more time, heat and pressure, lignite changes into this type of coal with 65 to 75% carbon. Bituminous coal, after even more heat and pressure, it changes into this form of coal with 75 to 85% carbon content. And anthracite is bituminous coal subjected to another million years of heat and pressure, and that brings us to levels of 85 to 95% of carbon content. This anthracite will only burn at extremely high temperatures. Question 3. A researcher analyzes a piece of coal and finds that it is unusually dense. And burns only when subjected to very intense heat. What is the lowest percentage of carbon that this coal is likely to contain? So, very dense, burns only at very high temperatures. Now we just read in anthracite. Only here we get information about temperature, burns at high temperature. That means our coal we are talking about in the question must be anthracite. What is the lowest percentage of carbon possible in this form of coal? We can see that here, 85%. So that's what we're going to write in the box, 85%. Second question related to this paragraph and information. Steel is made in a process in which iron is combined with carbon at extremely high temperatures. Which of the following types of coal might be most useful in this process? Again, the question is talking about extremely high temperatures, and we combine steel, iron with carbon, so we probably want very high carbon contents as well in our coal to avoid any contaminations. That means here as well, anthracite should be the correct answer. And the last question, drag and drop the appropriate type of coal into each box. So we just write the letters of the 4 possible coals that we have here. So what 2 boxes do we have? The type of coal most likely found closest to the surface of Earth, the type of coal that contains the greatest amount of carbon per kilogram. Again, second box, highest percentage of carbon, anthracite, so that's going to go in that box. So this is going to be D again, the type of coal most likely found closest to the surface of Earth. It was said here that we started with peat, and over time peat turns into lignite by basically getting deeper underground, which will increase the pressure and temperature. Lignite will change into the next form of coal by receiving more heat and pressure, going deeper into Earth's layers, and that will change into bituminous coal and anthracite in the end. And these are basically from top layer to bottom layer in Earth's crust, so peat is most likely to be found closest to the surface. So that's going to be A in the box here. Question 6 and 7 are based on the following information. Most seeds will germinate when they have moisture, oxygen, and the right temperature, but different seeds need different proportions of each of these ingredients. Most seeds require a temperature between 15 and 27 degrees centigrade to germinate, although some seeds, such as the maple, can germinate in far colder climates, and some other seeds, such as corn, require warmer temperatures. Before germination, seeds must absorb water, but too much absorption of water will encourage the growth of fungus, which can halt the germination process. So what information do we get here? We get information about the temperature that most seeds need to germinate, which is 15 to 27 degrees Celsius. We are told as well the general conditions that the seeds need: moisture, oxygen, and the right temperature. We are as well told that some seeds may be out of this temperature range, like maple, which is below 15 degrees Celsius, and some other seeds such as corn require warmer temperatures, so eventually above 27. And what other information do we get here? Too much absorption of water, so too much water will encourage growth of fungus. Let's have a look at question 6. Which of the following environments would be most suitable for the germination of corn seeds? A moist, sealed container at 26 degrees centigrade, an arid desert plain, a moist, plowed field at 30 degrees centigrade, an environment suitable for maple seed growth. So let's have a look at the different possible answers. A moist, sealed container at 20 degrees centigrade. Why is it not a good idea to have a sealed container? Because that means we already have moisture, so water will be there, but sealed means there is no oxygen gonna get into the container, so we can exclude A. We don't have oxygen, which is needed for germination. An arid desert plain. Arid means very dry, as deserts usually are. So let's exclude B as well. We don't have the water in situation B. C, a moist plowed field at 30 degrees centigrade. That sounds very good for our answer. Let's have a quick look at D before we cross anything out. An environment suitable for maple seed growth. So why is D wrong? Because as we read on top, maples usually germinate in far colder climates. So it's the exact opposite of corn. We are looking for corn seed growth, and it told us that corn grows in warmer climates than the average range. And that's what we have here. We have 30 degrees centigrade, which is above 27, which is good for corn. We have moisture and a plowed field, meaning the earth is soft and loose, so gases can easily diffuse in and out. So the seeds will be supplied with enough oxygen. Answer C is the correct answer here. Based on the information in the passage, which of the following is most likely true? Maple seeds can germinate in any temperature. Corn is difficult to grow. Water in limited amounts is vital to germination processes. Maple seeds and corn seeds require different amounts of oxygen for germination. Again, let's cross out what's wrong. Maple seeds and corn seeds require different amounts of oxygen. No information about that. It just says maple and corn seeds germinate at different temperatures. Maple cold, corn warm. Nothing about oxygen, so let's cross out D. C, water in limited amounts is vital to the germination process. That is probably the correct answer, but let's quickly look at B and A and see if we have nothing right here. Corn is difficult to grow. We don't get any information about this in the text, so not supported by the paragraph. Maple seeds can germinate in any temperature. That is not stated. It says maple seeds can germinate in, or usually germinate in, far colder climates. It doesn't mention anything about them germinating at any temperature. So we cross out A as well. C must be the correct answer. Water in limited amounts is vital for germination processes. Why limited amounts? Because it tells us in the paragraph above, if there is too much water, that will encourage the growth of fungi, and that can stop the germination process. So limited amounts of water are vital for the growth of, or for the germination of seeds. Question 8. During periods of intense activity, the cells of the body need more oxygen than the body is supplying, in a situation known as oxygen debt. During these periods, the body's cells briefly switch to anaerobic respiration, which produces lactic acid. The buildup of lactic acid in the tissues signals the brain to increase breathing and heart rates, thus supplying the body with more oxygen. After which of the following activities would lactic acid most likely be found in the body? So what does the paragraph tell us about lactic acid? Lactic acid is made by anaerobic respiration, which produces lactic acid. When does the body do anaerobic respiration? During periods of intense activity. The cells of the body need more oxygen than the body can supply in a situation known as oxygen debt. During these periods of intense activity, the body cells switch to anaerobic respiration, which produces lactic acid. So we are looking for, our answer should be something related to an intense activity. Walking to work doesn't sound very intense. Playing an intense game of chess, probably intense, but not an intense activity requiring a lot of muscle work. Taking an aerobics class, that sounds pretty intense to me. That is probably the right answer. Watching a scary movie, again, you will sit on your couch probably, and except you're watching a movie on a treadmill, but it doesn't say anything about that. So our correct answer is C, taking an aerobics class. During periods that are unfavorable for growth, some plants become dormant. Woody plants are protected during such periods by their bark. Perennial plants die above ground, but their roots remain alive. Annual plants die, but their seeds survive to continue the life of the species. Which of the following would most likely be a time of year during which plants might be dormant? Okay, not much to discuss here. That should be a pretty easy answer. Periods that are unfavorable for growth. Plants lie dormant, they sleep basically. And the period that is most unfavorable for growth is probably the winter. Question 10 refers to the diagram on the left here. The diagram on the left shows various layers of rock that have been deposited over time. Drag and drop the rock layers into the appropriate boxes. So rock layer 1, the oldest rock, the newest rock. Okay, we can see topsoil is the newest. We go from top to bottom. So at the bottom will be the oldest layer, at the top the youngest layer. Oldest layer of rock is D, youngest layer of rock is layer 1A. Question 11 refers to the food chain we see here. Which of the following conclusions is most likely to be true regarding the food chain above? Bass are the only fish that eat minnows. Minnows are bigger than bass. Bass benefit in some ways from the existence of copepods. Bass could simply eliminate the middleman by eating algae. Let's have a quick think about this one. So let's have a look at the answers. Bass are the only fish that eat minnows. So a food chain usually doesn't represent what's really happening in an ecosystem in terms of feeding relationships. It shows just one way that energy passes through the ecosystem from a producer to a final consumer. And what usually shows all the feeding relationships in an ecosystem is a food web. We don't have the food web here, so a food chain usually never gives us really information about what other organisms feed on minnows, for example, here, except bass. So A is a very tempting answer here, but A is not correct. There might be other fish in that ecosystem that eat minnows. It's just not shown in our food chain. It will be shown in the respective food web related to this food chain. Minnows are bigger than bass. No information about that, and pretty unlikely because bass feed on minnows. Bass benefit in some way from the existence of copepods. That sounds like a good answer. And D, bass could simply eliminate the middleman by eating algae. Yeah, but bass doesn't eat algae, and if they would do that, they would probably starve themselves. So that answer just doesn't really make sense at all here. And there is no connection between algae and bass as well, no direct link, so bass just don't eat algae. Much better, bass benefit in some way from the existence of copepods. That is correct, because bass eat minnows and minnows eat copepods. If there were no copepods, then the population of minnows would decrease as well, which would lead to less food for bass and a decrease in the bass population. So bass do benefit from the existence of copepods. Question 12 is based on this paragraph. Passive protection is a method by which organisms protect themselves from predators, not by fighting, but by their appearance, smell or sound. Protective resemblance is a type of passive protection in which an animal's coloring mimics the natural environment, acting as a kind of camouflage. Protective mimicry is another type of passive protection in which a defenseless organism resembles a more powerful organism. Another interesting example of passive protection is a monarch butterfly, which smells and tastes so bad to other organisms that virtually no other animal or insect will eat it. Which of the following is not an example of passive protection? A chameleon changes its color to blend in with a leaf in order to avoid predators. We have just read above that protective coloring an animal's coloring mimics the natural environment. That's exactly acting as a kind of camouflage. That's exactly what the chameleon does. So this is an example of passive protection. We are looking for something that is not an example of passive protection. The non-poisonous scarlet king snake develops coloration very similar to that of the poisonous eastern coral snake. Again, protective mimicry is another type of passive protection in which a defenseless organism resembles a more powerful organism. That's exactly the case here. A non-poisonous snake resembles a poisonous snake. An orchid flower mimics a female insect in order to lure male insects to it, so the flower can be pollinated. That sounds like a good option. Let's check D first. An edible vine adapts its leaves to match the inedible plant that it is climbing. Again, that is protective mimicry here. It mimics a more powerful organism that has inedible leaves. So the correct answer here should be C. An orchid flower mimics a female insect in order to lure male insects to it, so the flower can be pollinated. This has to do with mimicry as well, resembling something else, but in this case it has nothing to do with passive protection. The point of mimicking here is to help it to get pollinated. That's why C is the correct answer. Next question. The density of seawater is 1029 kilograms per meter cube. 1 kilogram per liter is 1000 kilogram per meter cube. What is the density of seawater in kilograms per liter? Okay, we have to divide that by 1,000. So 1,000. So to get for the first example that we have here for the conversion, this tells us the conversion factor. So to get from kilograms per meter cube to kilograms per liter, we need to divide by 1,000. 1,000 divided by 1,000 is 1. That means we need to do the same to our density in kilograms per meter cube. 1,029 divided by 1,000 is equal to 1.029. That means answer C is the correct answer. Question 14 refers to the following scenario. Researchers in a particular city theorize that decreasing the greenhouse gas emissions in that city will result in better respiratory health for its citizens. In order to test this theory, they institute 2 programs. The first program provides commuters with financial incentives to take public transportation. And the second program initiates a respiratory care education campaign and provides free clinics for citizens suffering from respiratory health issues. During the 5 years after the researchers institute the 2 programs, greenhouse gas emissions in the city decrease by 50%, and a city-wide survey reveals that cases of illness due to respiratory problems have decreased by 65%. Researchers therefore conclude that the theory was correct. Decreasing greenhouse gas emissions resulted in better respiratory health for local citizens. Which of the following best shows why the researchers' conclusion is flawed? That looks like a more difficult type of question that can be found on the GED science test, basically evaluating experiments and finding flaws in an experiment or a hypothesis. So what is the wrong approach of the researchers here? So let's first have a look at the possible answers to make it a bit more easy for us. Answer A, they failed to compare the city's air quality to that of any other towns, so they don't know if greenhouse gases decreased more or less than they should have. They should have tested the city's drinking water too, since that has a greater effect on citizens' health than air quality does. Their conclusion doesn't explain the 15% difference between the decrease in greenhouse gases and the decrease in respiratory problems. They instituted 2 programs instead of 1, so they can't be sure which is responsible for the resulting health improvements. So, again, let's quickly go back to the paragraph. Researchers in a particular city theorize that decreasing the greenhouse gas emissions in that city will result in better respiratory health for its citizens. Which of the following? So, okay, let's have a look at the different answers. Which ones can we easily exclude? Let's look at A. They fail to compare the city's air quality to that of any other town, so they don't know if greenhouse gases decreased more or less than they should have. Well, for this experiment or for this project here, it's really not necessary to compare it to other towns because we can see a decrease in greenhouse gas emissions, and what the researchers wanted to see if that has an effect on the respiratory health of its citizens. So that's fine. We don't need to compare it to another city here. It doesn't matter whether it decreased more or less in another city. We just are interested in the decrease and how did it affect the citizens in our city. So we can cross out A. And B, they should have tested the city's drinking water too. Let's cross that out immediately. Again, it says, since that has a greater effect on the citizens' health, well, we don't get any information about that, really, and we are not interested in the citizens' health in general. We are interested in their respiratory health, which means the health of their lungs, basically, and anything related to the respiratory system, to the breathing. And we don't breathe water, we breathe air. So that's why we can exclude answer B. Their conclusion doesn't explain the 15% difference between the decrease in greenhouse gases and the decrease in respiratory problems. They don't need to. Maybe just decreasing the greenhouse gases a little bit already has a big effect on the health of the citizens. It doesn't need to match. So, all good here. D, they instituted 2 programs instead of 1. Yes, that is a problem because we want to know which program leads to better respiratory health. If we do 2 at the same time, well, we can't really say which one was beneficial. So they can't be sure which is responsible for the resulting health improvements. Yes, that is the correct answer here. And thinking about the scientific method as well, we always, in an experiment, we always should have one variable that we are testing. Again, here we have 2 variables that we are testing, so we can't be sure which one in the end had the effect on the outcome. Next question, question 15. Lobsters are crustaceans commonly found in the waters of the Atlantic Ocean off the North American coast between Maine and North Carolina. Researchers studied the weights of these creatures over a period of few years. Some of these results are displayed in the table below. So we have the years 2005 to 2009, no year skipped, and we see the average weights with 0.43, 41, 37, 43, and 38. The researchers hope to find the most commonly occurring lobster weight for the lobsters studied during the 5-year period shown. The researchers must calculate the average mode median range of the weights, which is one of the 4 possible weights here. So this is basically looking for a definition and then you knowing how to do that. So the most commonly occurring lobster weight. Let's look at the table. Over the 5-year period, which is the most commonly occurring lobster weight? The only value that appears twice is this, 0.43. This is the most common lobster weight. And the value that appears most often in a data set is called the mode. The median is the middle value. To find the median, we need to put all the values in order from lowest to highest and then pick the middle value. We can do that here quickly. The lowest is 0.37, then 3.8, then 4.1, and 4.3, and 4.3. We have 5 values. The middle value in this case is 0.41, so that would be the median. The range is the lowest minus the highest value, so 0.43 minus 0.38, which would be 0.05. And the average is adding all the values together and dividing by the number of values that we have added. So adding these up and dividing the sum by 5 would give us the average. Here we are looking for the mode, the most occurring value, which in this case is 0.43. Amy tracks the monthly snowfall in 2 areas over a period of several months. One area is a region of high elevation and the other is an area of low elevation. The table below displays her results. November, December, January, February, March. In every month we have low and high elevation, and here we see the results of snowfall in low and high elevation. Question is, what is the mean of the data shown in the table? You may use a calculator. So again, what do? We have to add all these values up. That will give us, I did that before already, so that looks horrible. So we add all of them up, and the sum of all of these is 9.3. And how many values did we add up? We added up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need to divide this by 10, and 9.3 divided by 10 is 0.93. That is the average or the mean of this data set. Scientists calculate the pressure within a gas by using the following equation. P equals nkt over V. In this equation, P is the pressure of the gas and the number of particles in the gas, K is the gas constant, T temperature, and V is the volume of the gas. If the number of particles in the gas decreases, which of the following changes will increase in the pressure of the gas? If the number of particles in the gas decreases, which of the following changes will increase in the pressure of the gas? So basically, what will increase the pressure of the gas if N decreases? So N decreases. So to increase the pressure, we need to either increase K, increase T, or decrease V, because V is in the denominator. Making the denominator smaller will give us a bigger pressure. So let's see which one of these is true. Decreasing both the volume and the temperature of the gas. Decreasing the volume sounds good, but we don't want to decrease the temperature. Increasing both the volume and the temperature, that's just the other way around. We don't want to increase the volume, we want to decrease the volume. Increasing the temperature is fine. So both A and B are not correct. Increasing the volume and decreasing the temperature of the gas. But that is exactly what we don't want. We want to decrease the volume and increase the temperature. So not C. Decreasing the volume and increasing the temperature of the gas. That's exactly what we want to increase the pressure. All right, that's it for part 1 for the GED Science Practice Test 2. This was GED Live at PALS, and if this video was helpful for you in your preparation for the GED Science test, ring the bell so you won't miss any future videos, and subscribe to our YouTube channel. Have a great day and see you for part 2.